Hey everyone, this is All Core Devs Execution Layer meeting 165. This is issue 815. My chat's going through. No, can someone share? Oh, it is. Okay. Anyway, a couple technical difficulties, but we can keep moving. Anyway, this is issue 815 on the PM repo, and I am subbing in for Tim Bako today. Okay, looks like we have, is somebody from Dadab? Sorry if I'm not saying that. Yeah.
Can you hear me?
Yeah, cool. Okay, so the first thing up is we do have an SSD impact analysis that was done by Dadab. If y'all want to take it away, you can screen share and give us a look.
Sure thing. Thanks, Danny. Let me just share my screen. All right. So thank you for hosting this this meeting and inviting me here. So over the past 3 weeks, we've conducted another study. This one has to do with the migration of the RLP format to SSZ of some MPT commitments, which are stored in the receipts and transaction route, respectively. So this is obviously joint work with some of my colleagues. One of them is on this meeting as well. Yeah. So what was the original scope of the study? So the issue with making changes to execution layer data structures in the block header is that there's some protocols that might actually be using these and performing proofs on top of these. So these two EIPs, so that's 6466 and 6404, are migrating the encoding from RLP to SSZ. Now, what is the impact of such a change on these protocols? We've tried two different approaches for completeness. So in one approach, we've analyzed all smart contracts deployed on Ethereum. So we have a data set for that on contract library. So the static analysis, and the other approach employed dynamic analysis. So we actually looked at the transaction behavior and tried to determine whether there were smart contracts that are actually doing verifying proofs over these data structures. Yeah, so, and we already had an idea that perhaps, decentralized bridges might be doing this sort of thing. But, over like a couple of years ago, we also saw historical blockchain events oracles and other weird stuff that cannot be discounted. So we found, and examined these projects. And try to determine what is the provenance of this RLP encoded data. Is it coming from layer 2? Is it coming from layer 1 itself? Now, note that in this meeting we're discussing whether to make changes to layer 1, but not layer 2. So if layer 2 changes, then it shouldn't affect. It shouldn't affect. Decisions that are being made on layer 1. Yeah, and then of course there's other things, like for instance, is some of the data being relayed via centralized keepers and things like that. So if there's some element of centralization through which some of these data is being passed through, then perhaps even if the changes are being made, the centralized systems can be upgraded. Okay, and of course, all of this study has been done on recently used or high balance or part of known protocol contracts. Now, if we determined that the protocol was affected, we explored upgradability options. Okay, so to get into a bit more detail about the the effect of the changes. So here's the Ethereum block header. Here's some of the fields. There's three roots there. There's a state root, which is a root hash global state, also encoded using a Merkle tree, transactions roots, and receipts root. Again, so these are roots of Merkle trees containing transactions and receipts respectively. So 6466 is changing the encoding of the transactions from RLP to SSZ, and in case of the receipts as well. So this will obviously make a big difference to the hashes that are going to be calculated. So if there was some smart contract which is actually re-verifying these, then those will actually be broken. So throughout these 3 weeks, we've determined that actually there are 3 protocols that will be affected by this. So one of them is layer 0. And in this case, layer 0 is also being used by ZK Bridge in some way. So, both of these protocols are affected. Specifically, one of the light nodes is being used and it's going to be affected. In the case of telepathy, which is doing very complicated things, that is also going to be affected. Now, in all 3 of these protocols, we've also found out that there are upgradability options. And in all cases, only EIP 6466, so the receipts root, had an impact. Now, the estimated impact is, subjective, but so for instance, the subjectivity comes from the fact that, how can we determine whether the protocol is easy to upgrade? We're not exactly sure how easy it is, but we've seen that, for instance, if they're using certain software engineering patterns, we know that they're upgradable. How often is the protocol used? And then, especially on the more complicated protocols, there's alternative configurations, and in some configurations the protocol is affected, and in some it isn't. Now, most importantly, before we started the study, we already had an idea that perhaps some of these decentralized bridges, like an Optimism or Polygon, there is a possibility of them being affected. And indeed, these bridges were being flagged up time and time again in our analysis because they were doing proofs of RLP encoded commitments. And but in actual fact, these are not being affected. I mean, these were out of scope because in both cases, for instance, Polygon and Optimism, the data was coming from layer 2 and being verified on layer 1. Okay.
Do we know when data goes from layer 1 into layer 2? Are they utilizing the layer 1 commitments, or is that a blind spot?
So what we did is we looked at the protocols that were deployed on Ethereum, but then most of these larger protocols, they would have similar contracts on other chains. So when we found that they were actually doing verifying these kind of proofs on layer 1 from layer 2 data, we also checked on the other chains whether a symmetric thing is also happening.
Right. Okay.
And in this case, we didn't find that was happening. But say, for instance, in the case of layer 0, we did find that was happening.
Okay, thank you. Okay,
so I'll go into the 2 different approaches we used. So we used static program analysis, where we literally try to find, just by looking at analyzing smart contract bytecode, just to be like fully complete, whether the bytecode were implementing, RLP decoders and using that, say, for instance, in Merkle tree proofs. Now, it looked a bit daunting at first, but we actually did manage to mechanize an analysis for identifying these. And the main insight from this is that all of these RLP libraries, if they want to decode RLP correctly, they need to actually contain some constants, such as the ones that I'm selecting here, because these are actually needed because you need to do comparisons, or you need to subtract these constants to get, for instance, length fields and things like that. So what we did is we tried to see whether there's like patterns, such as, for instance, the variable is being compared to a constant in either direction and things like that. So, in multiple different ways. And it turns out that, this analysis yielded quite a few contracts, and, I'd say most of them they weren't actually false positive. Indeed, having, a combination of those constants being used in expressions, such as comparison expressions, and then using that to, decide, which part of the loop to execute and things like that. It was basically an RLP decoder. Now, one other thing we did is, because Ethereum bytecode doesn't have variables, what we did is the analysis was performed on a lifted version of the bytecode. So in contract library, we have this constant data set of decoded smart contracts and, decompiled smart contracts, and they're decompiled up to various levels. And one of those levels is tree address code, which is very faithful to the original semantics of the bytecode, but it contains variables instead of stack operations. And so once you have that, and it is easier to perform comparisons, looking at certain patterns in the code. Okay. And of course, there's other things you need to do. So the compiler generates a lot of code which needs to be optimized and things like that. And we had analysis passes to de-optimize some of the code. It wasn't work which was conducted for this, but it is a data set that we're constantly analyzing, for security vulnerabilities and things like that. Okay, so we've also tried a second approach to find, affected contracts. And the reason why we wanted to try two different approaches is so that we can get kind of like more confidence out of the, data sets, and, be sure that, each approach has its own blind spot, but, if you combine two approaches together, you get better results. So via dynamic analysis, what we actually tried to find is identify contracts, specifically some functions within those contracts, that received RLP encoded data as part of their call data, as part of their arguments. Now, how do you do that reliably in order not to get a lot of false positives, not to, because what's special about RLP encoded data? And we will see in the next slide, assuming that the RLP encoded data is of type bytes, then because of the way ABI encoding works, so in ABI encoding, you'd have the first 4 bytes being the selector, and then you've got chunks of 32 bytes being individual arguments. Now, when you have something of type bytes, apart from having a pointer to where the bytes start, right before the actual data in that byte array starts, so I'm putting my cursor here, right before that you have a length. You have the actual length of the the array. in the next 32 byte and chunk and so on. And it also happens to be the case that RLP encoded data also contains a length field, and it's funcally encoded because you've got the first byte gives you the length. Yep.
Sorry, that's just somebody I muted them.
All right. No worries. Yeah, so the first byte is actually the length of the length, and then you've got the actual length here. Of course, there's like differences here, but if you go through, as we did, like all the call data over 1 million blocks, and you check for these heuristics like this, we ended up getting a pretty good data set of around 1,000 smart contracts that were actually doing RLP decoding. Now, there was also a source of false positives in this data set because there are many contracts, such as, for instance, Uniswap flash swap or things like that, that just relay the call data from one contract to another without actually interpreting it. And so what we did there is we actually assessed for every smart contract, for every public function that it implements, the number of times it actually is receiving RLP encoded data in its arguments. So if it was receiving more than RLP encoded data and more than 10% of the time that it was being invoked, then we put it in the data set to be inspected later. So then what we did is we combined these two data sets, and we found out that it's mostly the same contracts that were being flagged. And we inspected the most popular contracts out of these data sets. And a lot of contracts and big protocols were flagged. As I said before, like Polygon and Optimism, BitTorrent, and many other protocols. And then obviously there were false positives as well. But I'm just saying, contracts or protocols that are decoding RLP encoded data. But most of them we found out by painstakingly going through each one of these contracts, one by one, trying to understand the protocol. There was always some reason why this protocol would be unaffected. And these are the three reasons, right? So one of the reasons was that the protocol didn't really do MPT proofs over this RLP encoded data, even though the data was RLP encoded. Such as the case of, for instance, when you have flash loan contracts or things like that, which relay call data arguments. So the second case, which is the most popular case, is that a contract was actually doing proofs, but the provenance of this data was coming from layer 2 chains or other side chains. And then when we looked at the same protocol again on other chains, we didn't find a symmetric relationship there. And then finally, the protocols were doing proofs over MPT commitment, but they were unrelated to in-scope IPs, such as, for instance, the state root or custom data structures that were being created from centralized systems. And so, these wouldn't be affected. So the important unaffected protocols that we found, so these are unaffected, were Polygon Bridge, Optimism, and BitTorrent Bridge. So BitTorrent Bridge was mostly used between Tron, I believe, and Ethereum. And we didn't find a symmetric path where like the implementation on the opposite chain, so the chain to which they were bridging to, was doing like similar proofs as was happening on Ethereum. Interestingly, there was another protocol called telepathy, which we marked as being affected, but in many cases, it was being flagged up as doing RLP encoded, proof commitment checks, but these were on the storage route. But then there was part of that protocol doing that on the receipts route as well. Want to say something?
Maybe later. So.
Okay. All right. So yeah, I mean, these are the affected protocols. So I'm going to give an example here on layer 0. This did exactly here on layer 0. It is validating one of the proofs, and the data is stemming from receipts route. In the second case, ZK bridge was integrating into layer 0 as an oracle. And in some cases we found that it was being configured with the ultralight node on layer 0, so that's also affected. And in telepathy, that was more complex.
Yeah, indeed. So hi, I'm Elias. I was one of the collaborators that worked on this report with Neville. Indeed, telepathy was a very different beast than the other bridges in the sense that it actually uses consensus layer data, but it turns out that they depend on the historical summaries field on the historical summaries buffer, which contains commitments from execution layer, and which of course right now are a function of receipts route. So when this changes, they will also be affected because they assume the data in the execution layer blocks are SSG, RLP encoded. So changing that will affect the smart contract. So.
Yeah, and of course it was also being flagged up for things that that were unrelated as well. Okay, so in conclusion, just from what we found out, we think that the impact is overall it's moderate, but in all three cases we found upgradability possibilities. Now I gotta stress that RLP encoding on and then reproving MPT commitments happens a lot on chain. And it actually took quite a bit of time to go through and filter out cases where this was going to be affected versus not. Most instances were indeed unaffected. In all three cases that we found in layer 0, for instance, the default inclusion library can be upgraded, and ZK bridge, if layer 0 fixes this, then it's going to fix ZK bridge, but they can also implement their own proof validator, which might add some technical debt. And again, in telepathy, they can also upgrade the inclusion proof logic. So thank you. Do you have any questions? And also, you can find the full report. I'll share it with you on the chat, and also this presentation as well.
Awesome, thank you. I have a quick question. Given the tools analysis and some of the kind of heavy filtering you had to do to remove what we think are false positives, what are the chances we miss something? What's the confidence level on completeness here?
Yeah, so the reason why we did two different approaches is in order to maximize this. Now, if you want to be even more rigorous than this, theoretically you would have to go through every single chain that we know about and repeat this on all the different chains. Now, the problem with that is that you will flag similar contracts, but they will not be exactly the same, perhaps. And so, again, you have to do a lot of inspections of all of these contracts. We did a little bit of this. So specifically, we looked at a sample of So we ran one of the dynamic analysis, which was easier to run on multiple chains. We ran this on a sample of BSC data. We ran a sample on Phantom data as well. But essentially, I mean, what was happening is that these protocols were deploying similar contracts on different chains. So if you find a contract which is doing that on Ethereum, you're most likely going to find the same contract doing it on other chains. And it's probably the case that there weren't protocols, bridges that were being developed for other chains with no similar symmetric contracts on Ethereum.
Got it. Other questions?
Yeah, so
Lucas?
If we're talking about other chains and coordination, right? Because this is not a blocker for us or anything. Do you have the tools for this analysis available for them?
Yeah, so part of the tool chain is open source, but another part is closed source. So we can give you accounts, for instance, on one of the tools we have internally called Watchdog, and some of the analysis can be repeated. Again, so on the other chains we're limited, but on the Ethereum chain we fully support that.
Mm-hmm. And second question, so if I understand the conclusions are there is no blockers, but it needs a bit of coordination when doing this upgrade with all affected parties.
Yeah, I would go with these three affected parties. I think Layer 0 already knows. I mean, they've read the or some of the developers have read this already. And then the other two we can contact them as well, and I guess the news will spread as well. We'll also put this up on our Twitter account. Maybe you can do the same thing on some of your accounts. But I don't think we'll find completely different protocols. They will be similar to what these protocols are doing.
Great, thank you. Any other questions? Okay, I appreciate it. We dropped the link in the chat for the full report. Check it out. Obviously, this isn't something we're making a decision on today, but this is really good information to help us make decisions in the future. There were a lot of discussion points in the chat. Is anybody want to surface anything for discussion now? Okay, great. Thank you for the detailed analysis. Next up are just general Cancun updates. Any testnet updates that we want to relay or other updates relevant for today?
Yeah, we have devnet 7 up and running since last Friday, and the testnet's been finalizing. We've also submitted a bunch of blobs to it and triggered at least 1 or 2 issues in the testnet. I think some of them have already been patched and some are still open. There's an issue tracker, so please refer to that for more details. And besides that, once we have all the patches put in, we're going to just continue spamming the network to see how we perform with the 3-6 blobs being full all the time. So far, we've had it for short durations of time, but we haven't had it for a long duration of time. And there's a message from Justin from the security team about a deposit processing issue. If someone from Teku could have a look, that would be great. Or I think Teku and Prism could have a look, that would be great.
What layer of the stack are we saying were the couple of issues? Networking, consensus?
I'd say it was networking issues. I think Marius has a lot more information on that, and if he wants to expand on that, I'd let him.
Yeah, so Geth had an issue with RP encoding of the transactions on the networking layer. So transactions weren't relayed correctly. That was fixed now, so it's that was the only thing. Transactions between Geth nodes were relayed, but not with the others, and the others implemented the split correctly. So
Thanks.
I think there was also an issue with the message size, right? With the too long messages being requested.
yeah, but that's not really something that we can change on our end. Basically, we can just say, hey, give us messages, give us these messages. And someone on the other side has to respond. There was an issue in Geth where we would not tell the other nodes the correct size of the messages. But I don't think anyone is really has implemented this part where we really use ETH60, like the new ETH68 mechanism, to say to filter messages and say, okay, we now want blob messages, or we only want messages that are smaller than X. So yeah, that's something that still needs to be implemented. I think some clients might even still send blob messages over ETH, over other ETH protocol versions. I think especially Ethereum JS, because they don't have ETH68 yet. So either they are not sending any blob transactions, or they're using ETH66, which is yeah, not good.
Okay, thanks for the updates. Any other Cancun updates?
Yeah, Nevermind has an issue. We will must have a fix as an image deployed soon. It is connected to message size tool, which was mentioned by Marius. So the fix is on the way.
Yes, we have a mechanism of limiting size of transactions which we are sending, but we had a bug in calculating size, like length of blob transactions, and it's already fixed. Will be merged in a few minutes, and probably image for devnet 7 will be updated today as well.
Assuming that all the fixes are in and devnet 7 is relatively stable, do we then start planning? Would you guys prefer that we start planning the next one with all the other EIPs, or should we continue just keeping devnet 7 up and stressing it more? I'm not sure which approach we want to take right now.
I know on the consensus layer, at least a couple of teams have voiced the desire to move towards the full feature set for the next testnet, but in terms of the timeline, if we want to stress devnet 7 and there's some iterative pure 4844 updates that people want to do, then that makes sense. So preference for when we move to do so, but I don't know if there's a time preference for when we move.
So we don't have 4788 yet in the code, and I think at least one or two other EIPs. I would rather use this time to to stress test devnet 7 and in parallel work on getting those other things in, and not wait with the stress testing until the next devnet.
How about we add all the tests required for the next devnet onto Hive so that we can already, anyone who's ready can already start testing and making sure Hive is green. And in the meantime, we keep devnet 7 around and just stress test devnet 7. Would that be a good, doesn't block anyone approach?
Sounds good to me.
Yeah, I think so. We don't need to be setting the date for the next testnet, but allowing clients to be in the position to move there. Mario?
Yeah, do you mean with the Hive test, do you mean the EIP tests or the, for example, the dev peer-to-peer issues tests, or both of them?
Yeah, I guess ultimately both, starting with consensus and then moving to dev P2P makes sense, unless you think otherwise.
Yeah, we are still working on having all the AP tests. I think in a couple of next weeks, we should have them ready for testing. Yeah.
Gotcha. And I believe the EIPs are going to be dominantly kind of consensus tests rather than dev P2P tests in terms of the workload on your end. Contrary to 4844.
Yeah, definitely. I think 4844 was like a one-off, because of the different transaction formats that we used in the header versus the peer-to-peer. So that's not gonna be an issue for the other APIs. Yeah.
Yeah, so Barnabas, just to echo that, obviously, unless major issues are found with devnet 7 and pure 4844 testing, the intention is that the next devnet would be full featured for Cancun. But we're not setting a timeline for that next testnet. We're gonna allow people to develop the full feature set while stress testing devnet 7.
I'm talking about issues with 2.4/3.6. We only had 3.6 for a short duration, so I think it's too early to make a call on either one.
Cool, and we can, on Monday, we have a 4844 call. We can spend some time talking about if there's networking stuff that surfaced. Looks like Nimbus is having issues, but we don't really have clarity on if on our small testnet 3.6 is changing the impact. But we will continue to bring that up either on the call at 4844 on Monday if we have time. I mean, if we have information, or on the consensus layer call next week. And Barnabas, just for your information, the latest consensus layer spec release and tests does have the full feature set on the consensus layer. So if you're building the spec for that devnet, you can point to whatever the latest release is.
Okay, great, thanks.
Okay, other Cancun discussion points? Did someone unmute? Okay, good. Moving on, there's an item from Mikhail and myself, a should override builder flag being introduced into the engine API. This was discussed on the consensus layer call last week, and general consensus that getting this flag in the engine API is high priority for them and very easy. It's because it can be introduced and always sets a policy in the execution layer and a no op if they feel like on the consensus layer. So you can kind of introduce the flag and then add feature functionality to it over time. But Mikhail, can you give us the information on this and what people are thinking.
Okay, so I'll just quickly go give the context on this flag, and then the discussion on whether include it into Cancun. So should override builder flag. The proposal is to add this flag to the get payload response. It's basically true or false. This is the way the EL to communicate to CL that there is some censorship is happening in the network, and CL should make its own decision about that. So the way it's supposed to work, so EL will have some heuristics and to find the evidence of censorship, transaction censorship in the network. And according to these heuristics, made a decision and return this flag with the build payload. So we favor client diversity for implementing these heuristics, so they're completely unspecified for this reason. And also, if EL does not implement any of the heuristics, it should always return false. So yeah, as Dennis said, it should be no op. And also, consensus client may also ignore this flag, even if it is set to true. So it's completely free process for both parties, and consensus may use other sources of to feed it into the decision-making process about censorship. So the main reason why this flag should be returned by EL is that EL has information like mempool and the reorgs, which is a pretty big chunk of data that it does not want to expose via any API, and it doesn't make sense to be exposed. So that's the way it is supposed to work. And getting back to the Cancun, so we want to include this into Cancun. As Dennis said, the CL clients are on board with that. And considering that the engineering complexity is really low. And also we have a prototype in Geth of those heuristics. Marius can give more details on that. So considering that the complexity is low and the utility is quite high of that flag, so the proposal is to make it into Cancun. That's basically it. Lucas?
So my question might be premature. Maybe Marius should come first. But the question is, what's the status of research of these heuristics, and are there like many of them proposed? Are they in any way like checked on historical data, right? Against historical data. And my question stems from actually client diversity. So think that a client would implement this in a way that would flag lots of false positives, right? And then stakers might be discouraged to use this client because they would get lower rewards. So it may affect like this kind of things too. So hence my question.
I suppose in theory that is possible. You know, if you had a client that always said true and you couldn't override that, and your CL listened to the EL, you know, in the extreme, obviously you would have lower rewards. That said, I know there are discussions of a number of simple heuristics. For example, transactions sitting in the mempool for X time that certainly could have been included profitably in a block, where you know these end up looking like pretty deterministic. But I also, you know, this is primarily to elevate the EL to have a voice in, you know, the fallback functionality. You know, and there's any number of reasons, even beyond censorship, that you might perform such fallbacks. But are there any write-ups or deeper discussions of potential heuristics here? I know Potes has thought about them.
So I have not really thought about it. I just implemented this very simple heuristic. If a transaction has been reorged out at least 2 times, no, 3 times, then we suspect that someone is censoring. This is just the first heuristic that I thought about. So it's not back tested. It's not really, yeah. It's just something to prove that it's actually possible to implement this and show that it's very easy to implement those heuristics.
Because
So okay, let's say someone reorg transaction 3 times. You have this you managed to find this out, and so for how long do you return this flag?
Forever afterwards.
Okay, that's probably also not optimal.
No, as I said, this is very much a draft of this concept. It's just to make sure that this concept kind of works.
yeah, I mean, and defining optimality is certainly up to the client, right? Like, if you have any heuristics go off, you can flip a coin.
Also, good idea
Then to
from
return true false. There's all sorts of ways if you are concerned about that to allay those concerns. Go on, sir.
good idea from Ben that if we have empty blocks, fairly empty blocks, that could take transactions from the transaction pool but didn't, right? So someone is trying to like censor the block space in general, not certain transactions. Good idea for a heuristic.
Yeah, I mean, I guess the way I think about it is primarily the EL has a lot of information. This gives a way for the EL to give an opinion, to voice something about that information. You know, and because it's very wide open, then you know, you have the faculty to decide how, when, and if to voice that.
Yes. Yes, I'm totally agreeing with the concept, right? The concept is great, and we should implement it ASAP. And it's very simple because we can right now just return false for some time. Just wanted to highlight that this opens quite a not trivial problems that may have better or worse solutions that, in my opinion, need some could be helpful to have some research on. That's what I meant.
Agreed.
One thing that I noticed also about the code, I'm not entirely sure about it, but I was thinking that if someone posts a transaction with a bit of a low fee or a low priority fee, and that's the reason why it's not included, with the current approach that Marius has, this might flag as censoring when it's actually not. No?
No. It's like this only tracks if a block gets reorged out, and like we see 3 blocks in a row getting reorged out and they contain the same transaction, then we suspect someone is doing hard
So
censorship.
we're talking about only reorging, not being included.
Yes.
Okay.
The heuristic that I implemented, yes.
So the main question here is anyone opposed to getting this into the engine API spec? It is a single Boolean flag in one method that, other than implementing the engine API, you don't have to do anything immediately. This would probably be slated for that full feature devnet that we're talking about, called devnet 8. Is anyone opposed to that? We have support from the consensus layer teams. Marius, right now we do not have EIPs for the engine API. The engine API is more of an implementation detail around the outer consensus spec, but I'm not sure if there was this is sarcasm or not. Docred?
Sorry, what are we going to do with this flag when we have it?
In the event that the execution layer says true, the consensus layer can decide to fall back to local building instead of that boost or any sort of outer block building.
Oh, but sorry, that doesn't. I mean, okay, so but then Marius's approach of detecting it doesn't make sense because he is detecting it using reorg blocks, right?
Right. So in
implementation.
that, okay.
Sorry, go ahead.
We can debate that, right? Because if the attacker has the ability to reorg, then they're going to just reorg it again. We can debate the technique.
Yeah, I mean,
There are lots
so
of
like, I mean, I
techniques
think
that-
like such a flag only makes sense if you can detect an attack and you have a remedy for that attack. Like, yeah, if like we can detect block builders are not including it, then that flag might be interesting. But if like we're detecting something completely different and extrapolating from that, oh, censorship is going on, then it doesn't make sense to like affect this part of like, I don't know, the two that don't seem to be in alignment there.
That there are many other heuristics that do not involve reorgs. You're right. There is a nuance to the reorg one.
Right,
and you
but
can
I'm simply
actually prevent
saying,
the
like,
reorg.
I mean, it definitely has to be one of those. Like, otherwise, it doesn't make sense to me.
Agreed. I think the most obvious ones are monitoring mempool with respect to what was included in the main chain, and that does not have to do with reorgs and can allow for something. There might be
in that
information
case, you have
about-
to make a judgment about the tips. But I think like you can say if transactions with lower tips are getting included, then you could like say a censoring attack is probably going on.
But I do think you and I agree that there are techniques that are valuable here and relatively simple.
And this also, I think this heuristic was kind of naturally grown, and in the beginning it was just a log output if we have this, if we see this case. So basically just an indicator that there's censorship going on, and for that one the heuristic was fine. I agree that for falling back to local block building, this heuristic is not really on, doesn't say anything. So yeah, as I said, the heuristic was something that was thought up in like 5 minutes just to see that the concept works.
So yeah, thanks a lot for the discussion. Recapping, if there is no opposition on the call, if anyone listened to us and has an opposition to this tiny change, please express it in the EIP. Well, sorry, in the PR. Yeah, we have no EIP for that. And I will be aiming to merge this on next Monday. So that's the plan.
Great. Thank you, Mikhail. Okay, next up, 4788 bounded storage has been merged. Alex, do you have anything you want to discuss here?
Not really, mainly just calling it out. We've kind of had a little bit of back and forth on the design, and the PR that was merged is kind of the last, or sort of, the product of all those conversations. So basically it's storing block roots from the beacon chain, and the storage is now bounded using like 2 ring buffers. And yeah, I'll just point you to the PR if you want to see the details. A few people have implemented it and said good things. So sounds like this is the way forward for this EIP right now.
Great. And this had no impact on the consensus layer spec.
Right.
Affirmative.
Yep. Yeah, that's been handled other places. There's support for it in the engine API. So that's all set. And then, yeah, all this was really doing was just changing some of the implementation details of the actual precompile, but otherwise, same basic idea.
Great. Any questions for Alex? Thank you. That's all we have on the agenda for today. Are there any other discussion points, announcements, concerns at this point? Okay, thank you, everyone. I believe Tim will be back for the next version of this call in 2 weeks. Talk to you all very soon.
Thank you.
Thanks, bye.
Thank you.
Thanks,
Bye.
Danny. Thanks all. Bye.